Hello, and welcome back to Data Science Nepal. And today we're diving into one of the most critical sections of the Masters in Data Science entrance exam, the mathematics section. The mathematics section covers 25 multiple-choice questions out of 100. Are you ready to tackle some model questions? In this video, we'll solve a variety of problems step by step, covering key topics you need to master. By the end, you'll have a clearer understanding of the concepts and techniques required to excel in this section. Grab your pen and notebook, and let's get started. The model question begins with an example question stated as, if a random variable x takes values 0, 1, 2, 3, and 4 with respective probabilities 0.6, 0.1, 0.1, 0.1, and 0.1, then the mean of x is? And the options are 0.1, 1.0, 0.5, 2. Now, let's obtain the solution to this question. Mean of a random variable x can be expressed in terms of expected value of x as x, and it is defined as summation I runs from 1 to n xipi, and now this can be expressed as the sum of product of the values of random variable x and its respective probabilities. Here, 5 terms are available, so the mean value is x bar equals summation I runs from 1 to 5x ipi equals 0 into 0.6 plus 1 into 0.1 plus 2 into 0.1 plus 3 into 0.1 plus 4 into 0.1, and this results to a value of 1. So the correct option is option B, 1.0. Now, let's move to the next question. The question states that the divergence of gradient of a vector function is equivalent to, and the options are Laplacian operation, curl operation, double gradient operation, null vector. Ready to decode this problem? Let's do this. The Laplacian operation is defined as del squared v. The curl operation is defined as del cross v. The double gradient operation is defined as del v, and the null vector is a zero vector. The del operator is defined as del by del x, del by del y, del by del z, and v is a vector function. We also need to know about gradient, divergence, and curl operations. The gradient of a vector function v is defined as del v. The divergence of a vector function v is defined as del v, and the curl of a vector function v is defined as del cross v. Here the divergence of gradient of a vector function is to be obtained. The gradient of a vector function v is defined as del v, so this can be written as divergence of del v. The divergence of a vector function follows dot operation by del, so this results as del v, and it is further simplified as del squared v, which is a Laplacian operation. Therefore, our correct option is option A. However, note that the double gradient operation del v is similar to Laplacian operation del squared v, but they are not equal at all. We are going great. Be ready for the next question. Question number 2 suggests an integration problem where if integral 0 to 1 by under root 1 minus x squared dx equals m pi, then the value of m is
0.
1 by 2.
1. 2.
Let's evaluate this integral. The integration of this standard integral is tan inverse x by under root 1 minus x squared. Applying the limits 0 to 1 resulted as tan inverse infinity minus tan inverse 0 equals m pi. The value of tan inverse infinity is 90 degrees, which is pi by 2, and the value of tan inverse 0 is 0. Simplifying it resulted in the value of m to be equals 1 by 2. Let's check our options. We see that option B is the correct answer. Now it's time for question number 3. Let a n equals summation k runs from 0 to n by n squared plus k, for n belongs to natural number, then the sequence a n is convergent, bounded but not convergent, diverges to infinity, neither bounded nor diverges to infinity. Let's crack this out. A n equals summation k runs from 0 to n by n squared plus k, for n belongs to natural number, that is 1, 2, 3, 4, and so on. For n equals 1a1 equals summation k runs from 0 to 1 by 1 squared plus k equals 1 by 1 squared plus 0 plus 1 by 1 squared plus 1 is equal to 1 by 1 plus 1 by 2, and this results to be equal to 1.5. Similarly, for n equals 2a, 2 results to be 1.233, and for n equals 3a, 3 results to be 1.1560. We can clearly see that the values are in decreasing order. Similarly, we can sum for the last term, an. We can observe a pattern over here that the first term, a1, produces 2 terms, a2 produces 3 terms, a3 produces 4 terms. Similarly, the last term, an, produce n plus 1 terms. We can also observe that as n grows larger, it dominates the value k. Let's understand with an example where n equals 10,000, then an equals 10,000 by 10,000 squared plus 1 plus 10,000 by 10,000 squared plus 2, and so on. Here the value of n squared is very, very larger in comparison to the value of k equals 1, 2, 3, and so on. Hence the value n squared dominates the value k. So n by n squared plus k can be written as n by n squared, and it further simplifies to 1 by n. So each term in an is approximated to 1 by n, and there are total n plus 1 terms. Therefore an equals n plus 1 multiplied by 1 by n. It is further simplified as 1 plus 1 by n. Now, as n tends to infinity, an equals 1 plus 1 by infinity, where 1 by infinity is 0, so the an converges to the value 1. So our final sequence will be a1, a2, a3 up to an, and their values are 1.5, 1.233, 1.1560, up to 1. We can clearly observe that the sequence an is convergent as it converged to 1. It is also a bounded sequence since the values are bounded between 1.5 and 1. Now, let's check our options. Option A, convergent, and this is correct since our sequence is convergent. Option B, bounded but not convergent, is incorrect since the sequence is convergent. Option C, diverges to infinity, and option D, neither bounded nor diverges to infinity, both are incorrect. Hence, we got our correct answer as option A, convergent. Moving on to the next question. The integrating factor of the differential equation xl n of x dy by dx plus y equals 2 ln of x is? And the options are L n of log of x, e to the power x, L n of x,
X.
The standard linear format of differential equation is dy by dx plus p of x times y equals q of x. So let's convert the problem into standard format by dividing xl n of x on both sides. We obtain dy by dx equals 1 by xl n of x times y equals 2l n of x by xl n of x, simplifying it, and comparing with the standard format we obtained that p of x equals 1 by xl n of x, and q of x equals 2 by x. Now the integrating factor if for the first-order linear differential equation is if equals e to the power integral of p of x dx. Further solving it, if equals e to the power integral of 1 by xl n of x dx. Now to evaluate this integral, let u equals ln of x. Differentiating both sides with d by dx. We get du by dx equals d by dx of ln of x. The derivative of ln of x is 1 by x, so du equals 1 by x times dx. Substituting this value in our integral, we obtain if equals e to the power integral 1 by u du. The integration of 1 by u du is ln of u, so we get if equals u, where u equals ln of x. Let's check the options. We see that option C, ln of x, is our correct answer. Doing great? Let's try another one. Moving to question number 5. The slope of the normal at the origin for the curve y equals cos x plus 2 e to the power x is? And the options are -2,
0,
infinity, 3. Let's solve this out. Differentiating the equation at the given point gives the slope of the tangent at that point. Let's evaluate the slope of the tangent at first by differentiating with d by dx. The derivative of cos x is minus sin x, and the derivative of e to the power x is e to the power x itself. The slope of the tangent at origin, that is x equals 0, is dy by dx at x equals 0 equals minus sin 0 plus 2 e to the power 0. The value of sin 0 is 0, and the value of e to the power 0 is 1, so the result obtained is equals 2. The slope of tangent, say, m1 equals 2. The tangent and normal are perpendicular to each other, so m1 times m2 equals -1 or 2 times m2 equals -1. Simplifying this results m2 equals -1 by 2. We got our answer. Now, let's check for the options. The values in the options are not matching our answer, that is -1 by 2. Don't worry, we are 100% correct. The options need to be adjusted. I wish you may not encounter any such errors in the question during the entrance exam. Let's look for the next question. Shall we? Okay. Question number 6. Complementary function of the differential equation d squared plus 4 times y equals tan x. To find complementary function CF of the given differential equation, we only focus on the homogeneous part of the equation. D squared plus 4 times y equals 0, where d equals d by dx. The corresponding auxiliary equation is d squared plus 4 is equal to 0. This quadratic equation produces imaginary roots as plus minus 2i. If the auxiliary equation produces imaginary roots, then the general solution for the complementary function is a cos theta plus b sine theta. Therefore, the CF equals a cos 2x plus b sine 2x. Now, let's check for the options. We see that option is the correct option. Hey there! Don't forget to check our other videos related to entrance preparation on our YouTube channel Data Science Nepal. Now, the next question is question number 7, which states that bounded monotonic sequence will be increasing if it converges to its. And the options are infimum,
Least bound. Supremum.
upper bound. To understand the concept of infimum and supremum, consider an interval between two numbers a and b as shown in the diagram. Those values that are small or equal to every value in the interval are the lower bounds, and the highest of the lower bounds is called an infimum. Similarly, any values that are greater than or equal to every value in the interval are the upper bounds, and the lowest upper bound is termed a supremum. Also, for a sequence to be bounded, it should not exceed a certain upper limit and should not go below a certain lower limit. Consider an example of a sequence from 0 to 1. The sequence begins with 0, contains intermediate values 0.1, 0.2, and terminates to 1. The monotonic sequence is a type of sequence that is either increasing or decreasing in order. In the question, the sequence is bounded, as well as monotonically increasing. Consider an example of this type of sequence as a(n) equals 1 minus 1 by n. In this sequence, the first term, a1, generates the output of 0, the second term, a2, generates 0.5, a3 gives 0.66, and for n tends to infinity, and converge to 1. Here the values are in the increasing order, and the sequence is also bounded between 0 and 1. In this case, we observed that this type of bounded and monotonically increasing sequences finally converge to its supremum value. To understand more on this topic, refer to monotone convergence theorem. Finally, we got our answer as supremum, and it is listed in option C. Moving on to the next question. In question number 8, there is an infinite series given as summation 1 by n to the power p is convergent if, and the options are p greater than or equals 1, p less than or equal to 1, p greater than 1, p less than 1. This type of series is called p-series. Given as summation 1 by x to the power p, where x is greater than or equals 1, and p is greater than 0. This type of series converge if the given improper integral 1 to infinity 1 by x to the power p dx converges. So, let's evaluate this integral for 3 different cases. Case first for p greater than 1. The integration of x to the power negative p dx is equals x to the power negative p plus 1 by negative p plus 1. Here p is greater than 1, so it can take any values greater than 1 such as 2, 3, 4, and so on. Consider a case where p equals 2, then the power of x will produce negative values. As x grows larger, x to the power negative values approaches 0. Let's understand with an example. If x equals 10,000, then 10,000 to the power negative 1 gives 0.0001. So as x tends to infinity, x to the power negative p plus 1 by negative p plus 1 converge to 0. Here for p greater than 1, the integral converged to 0. Case second for p less than 1. Similar to first case, we evaluate the integral. Since p takes the values less than 1, so consider a case where p equals 0. This gives the positive powers of x. Now, as x tends to infinity, x to the power positive values tends to infinity. Hence, for p less than 1, the integral diverges to infinity. Case third, where p equals 1, the integral 1 to infinity 1 by x to the power p dx is converted into 1 by x, where the integration of 1 by x is ln of x. Now, as x tends to infinity, ln of x also tends to infinity. Hence, the integral diverges for p equals 1. For 4 different cases listed in the options, the integral converge only for the case where p is greater than 1. Hence, if the integral converge, then our infinite series is also convergent at p is greater than 1. The correct option is option C. This one was tough, right? Let's try another one. Question number 9. The value of Laplace transform L cos hyperbolic 10t is? And the options are s by s squared minus 100, s by s squared plus 100, 1 by s squared, 100, 1 by s squared plus 100. Here's the solution. The Laplace transform of a function f of t is an integral 0 to infinity e to the power minus stf of t dt. Also, the cos hyperbolic x equals e to the power x plus e to the power negative x divided by 2. Here f of t equals cos hyperbolic 10t, and this equals e to the power 10t plus e to the power minus 10t by 2. Now applying the Laplace transform to the function f of t as Lf of t equals integral 0 to infinity e to the power minus st times e to the power 10t plus e to the power minus 10t by 2 dt. 1 by 2 is taken outside of the integral, and the integral of negative powers of e is evaluated where e to the power minus infinity is 0 and e to the power 0 is 1. Applying these concepts and simplifying the outcome, the final result obtained is s by s squared minus 100. Let's check it on our options. We found that option is our correct option. Let's look for our next question. Question number 10. Given a non-empty subset S of the real numbers on the interval 0 to 5, then any numbers greater than 5 is upper bounds of S, since it is greater than all of the numbers contained in S. Therefore, we can say that 5.01, 5.1, 6, and 7 are all upper bounds of S. Among all theses upper bounds, the one with the smallest value is known as dash of S. And the options are supremum, minimum, infimum,
maximum.
In the question number 7, we have already discussed about supremum, infimum, upper bounds, and lower bounds. We will discuss it again here with another example illustrated in the given diagram. Consider an interval of 0 to 5. The values below 0 are the lower bounds, and the values above 5, such as 5.01, 5.1, 6, 7 are upper bounds, and among these upper bounds the smallest one is known as the supremum. Hence the right answer is option A, supremum. This one was short, wasn't it? Let's move to our next question. Question number 11. Which of the following statements is true? And the options are: a number is rational if and only if its square is rational. An integer n is odd if and only if n squared plus 2n is odd. A number is irrational if and only if its square is irrational. A number n is odd if and only if n times n plus 1 is even. Let's test each statements one by one. At first, we need to know that a number is said to be rational if it can be expressed in terms of ratio as a by b, examples 5 by 2, 2 by 1, 3 by 2. Statement 1. N is rational if and only if n squared is rational. This is a bidirectional statement. That is, it must be true from both sides simultaneously. Let's check it out separately. 2 is a rational number and 2 squared equals 4 is also a rational number. Hence, this part of the statement holds true. Now, let's check for the other part. The square of root 2 is equal to 2, which is a rational number, but root 2 is not rational. It is an irrational number which cannot be expressed in terms of ratio. Here the statement is false. Hence, the first statement is false. So option A is discarded. Second statement. N is odd if and only if n squared plus 2n is odd. The odd number sequence can be expressed as 2k plus 1, and the even number sequence can be expressed as 2k. For the first part, if n squared plus 2n produce odd, then n must be odd. To verify this, take different values of n such as 1, 2, 3, 4, and observe the output of n squared plus 2n. We see that for n equals odd numbers, the outputs are also odd. Hence, this verifies this part, and it holds true. For the next part of the second statement, if n is odd, then n can be expressed as 2k plus 1. Substituting this in n squared plus 2n, we get a quadratic equation for k squared plus 8k plus 3. Now, for different values of k, all the outputs obtained are odd. Hence, n squared plus 2n also produce odds for n being odd. This part holds true, and since both the parts are true, the second statement is true statement. The correct option is option B. Let's move to the next question. Question number 12. Let a equals x squared such that x lies between 0 and 1, and b equals x cubed such that x lies between 1 and 2. Which of the following statement is true? There is 1-to-1 onto function from a to b. There is no 1-to-1 and onto function from a to b taking rationals to rationals. There is no 1-to-1 from a to b which is onto. There is no onto function from a to b which is 1-to-1. Let's figure it out. A equals x squared where the value of x lies between 0 and 1. Say 0.1, 0.2, 0.9. The square of these values are 0.01, 0.04, 0.81. We can see that all of these values are less than 1. Also, b equals x cubed, where the value of x lies between 1 and 2. Say 1.1, 1.2, 1.9. The cube of these values are 1.331, 1.728, 6.859. We can see that all of these values are greater than 1. Therefore, there is no any mapping or relation from A to B since the range of their outputs does not match at all. So the correct option is option B. Note that for a function to be 1-to-1 from A to B, different elements of A must map to different elements of B, and for a function to be onto from A to B, B must have every elements mapped to at least one element of A. Let's head for next question. The value of x from the equation log base 6x plus 2 minus log base 6x equals 2 is? And the options are 2 by 35, 35 by 2, minus 6, 1 by 18. Let's solve this one. When the logs are subtracted with the same base, then they are transformed to division as log base and a minus log base and b equals log base and a by b. Applying this, we get log base 6x plus 2 by x equals 2. Using another property of log, where if log base and x equals p, then it is transformed as x equals n to the power p. Using this transformation of log into exponent, we get x plus 2 by x equals 6 squared. Further simplification resulted the value of x to be equals 2 by 35. So option B is our correct option. Moving on to 14. Which of the following pairs of vectors is an orthogonal pair in R2 with respect to the inner product defined by u, v equals 2x1y1 plus x2y2, where u equals x1 x2 belongs to R2 and v equals y1 y2 belongs to R2? The solution begins as any two vectors u and v are said to be orthogonal with respect to their inner product u, v if its inner product is 0. That is, u, v must be equals 0. U, v is given as 2x1 y1 plus x2 y2. Now, let's check each option one by one. On examining each pair of vectors, none of them produced the inner product u, v equals 0. So none of the pairs are orthogonal. The options in this question need to be adjusted. Note that if standard Euclidean inner product, which equals x1 y1 plus x2 y2, is given, then option A will produce the value 0, and they would have been orthogonal. Moving on to 15. The rank of the matrix M equals 5, 10, 10, 1, 0, 2, 3, 6, 6s? To obtain the rank of any matrix, it should be converted into row echelon format, which is an upper triangular matrix, and then the number of non-zero rows present on the resultant matrix gives the rank of the original matrix. To convert the given matrix into upper triangular matrix, row operations are done. Interchanging row 1 with row 2 gives a value 1 at the top left corner of the matrix. Now the values below 1 should be converted into 0. So applying the operations on second and third row, where the values must be added or subtracted from row first, since we made the value 1. Now the next step is to convert the value 10 into 1 by applying row operation on second row. Finally, the number below 1, that is 6, should also be converted to 0 in order to create an upper triangular matrix. Applying row operation row 3, we finally got our upper triangular matrix. Here the first and second row are non-zero rows, so in total there are 2 non-zero rows. Therefore the rank of the matrix M equals 2. Question number 16. The eigenvalues of the matrix 4, 1, 1 for R. The eigenvalues lambda for a given matrix M are obtained through the solution of this equation. Determinant of matrix M minus lambda times I equals 0, where I is an identity matrix of the order of matrix M. Solving this equation, we obtain a quadratic equation, and its solutions are resulted to be lambda equals 5 and lambda equals 3. Let's check for the options. We see that option C is the correct option. Moving on to 17. Let f be a function defined by f of x equals x cubed for x less than or equals 0, and f of x equals x for x greater than 0. Which of the following statements about f is true? F is an odd function. F is discontinuous at x equals 0. F has a relative maximum. F dash of x is greater than 0 for x not equals 0. Let's test each options one by one. Option A says that f is an odd function. For a function f to be odd, f of minus x must be equal to minus f of x for all the values of x. Here f of minus x equals cube of minus x, and this is equal to negative x cube. Also minus f of x equals minus x. We see that f of minus x is not equal to minus f of x, so it is not an odd function. Statement O is false. Statement B says f is discontinuous at x equals 0. F of x equals x cubed for x less than or equal to 0, and x cubed is a polynomial, so it is continuous everywhere. Hence statement B is also false. Statement C says that f has a relative maximum. For any function f of x to have a relative maximum at point x equals c, then f of c must be greater than f of x in some neighborhood of c. Here f of x equals x cubed is strictly increasing, and f of x equals x is also strictly increasing. Since f of x is increasing everywhere, so it does not have any relative maximum at a point x equals c. Hence statement C is also false. The remaining statement is D, so it must be true. Let's find out. The derivative of x cubed is 2x squared, which will always produce values greater than 0 even if the x is less than 0. So f dash of is greater than 0 in this case. Also the derivative of x is 1, which is obviously greater than 0. Hence the statement D is true. Let's move to question number 18. Let f be the function given by f of x equals absolute value of x, or modulus of x. Which of the following statements about f are true? Statement first. F is continuous at x equals 0. Statement second. F is differentiable at x equals 0. Statement third. F has an absolute minimum at x equals 0. The graph of the function f of x equals modulus x is V-shaped, where it converts every negative value into positive values. For any function to be continuous, its left-hand limit, right-hand limit, and the functional value must be equal. Here at x equals 0, the left-hand limit, right-hand limit, and functional value all are equal to 0 for f of 0 equals modulus of 0 is equal to 0. Hence statement 1 is true. Statement 2 says that f is differentiable at x equals 0. For any function to be differentiable, it must be smooth. The curve of modulus x is V-shaped, which is not smooth at x equals 0. So f of x equals modulus of x is not differentiable at x equals 0. Hence statement 2 is false. Statement 3 says that f has absolute minimum at x equals 0. This is absolutely true, since the only minimum value for modulus x is at x equals 0. So statement 3 is also true. Here at the end we found that statements 1 and 3 are true. Let's check our options. We see that option D is the correct option. Moving on to question number 19. The number of bijective functions from set A to itself when A contains 10 elements is? And the options are
10,
10 square, 10 factorial, 2 to the power 10. For a function to be bijective, it must be 1 to 1, as well as onto. We have discussed this in question number 12 about 1 to 1 and onto function. Let's recap it. For any function to be 1 to 1, every element of A must map to unique elements of B, and for any function to be onto, every element of B must map to at least one element of A. If there are 10 elements in A and A maps to itself, then the bijective function corresponds to a permutation of 10 elements. Therefore, the number of bijective functions from set A to itself is 10 factorial. Option C is the correct option. Moving on to question number 20. The average value of the function f of x equals x minus 1 whole square on the interval from x equals 1 to x equals 5 is? The solution to this problem follows as f of x equals x minus 1 whole square, where the value of x ranges from 1 to 5. So the average is evaluated through the given integral 1 by b minus a, integration from a to b f of x dx. Here a equals 1 and b equals 5. So the integral is evaluated within the limits, and it results to the value 16 by 3. Let's check the options. We see that option B is the correct option. Moving to question number 21. The sum of the infinite series summation n runs from 10 to infinity. 3 to the power n plus 1 by 4 to the power n is? The solution to this question follows as S equals summation n runs from 10 to infinity. 3 to the power n plus 1 by 4 to the power n. It is further simplified as 3 to the power n times 3 divided by 4 to the power n. Or S equals 3 times summation n runs from 10 to infinity 3 by 4 whole to the power n. The fraction 3 by 4 is replaced by r. For a geometric infinite series, the sum to infinity is summation n equals 0 to infinity r to the power n equals 1 by 1 minus r for modulus of r less than 1. Since our series begins from n equals 10, so S equals 3 times summation n equals 10 to infinity r to the power n equals 3 times r to the power 10 times 1 by 1 minus r, substituting the value of r as 3 by 4 and simplifying the sum, we get the final result as 12 times 3 by 4 whole to the power 10. Let's check our options. We see that option is the correct option. Moving on to question number 22. If f of xyz equals x squared plus xyz plus z, then the partial derivative of f with respect to x at point 1, 1, 1 is? And the options are
0, 1,
3,
minus 1.
Let's solve this problem. The partial derivative of the function f with respect to x is del f by del x equals del by del x of x squared plus y z times del by del x of x plus del by del x of z. Here only x is considered as variable for the differentiation, and other terms such as y and z are considered as constants. So del f by del x equals 2x plus y z times 1 plus 0. Further simplification gives the value 2x plus yz. At xyz equals 1, 1, 1. The partial derivative gave an output of 3. So the correct option is option C. Moving on to the next question. Question number 23. The curve y equals x to the power 1 by 5 at 0, 0 has? And the options are a vertical tangent which parallel to y-axis, a horizontal tangent which is parallel to x-axis, an oblique tangent, no tangent. Differentiating the curve produces the slope of the tangent, and through the slope we can obtain the angle made by the tangent to identify its orientation or alignment. So differentiating y equals x to the power 1 by 5 gives the value 1 by 5 times x to the power 1 by 5 minus 1. At x, y equals 0, 0, the value of dy by dx is 0. Hence the slope of tangent is 0. Slope of tangent is also defined as tan theta, so the angle theta equals 0 degree. Hence the tangent is parallel to x-axis, and it is a horizontal tangent. We get option B as our correct option. Question number 24. The locus of the equation xy plus yz equals 0 is? And the options are a pair of perpendicular planes, a pair of straight lines, a pair of parallel lines. None of these. In the given equation, we can clearly see that there are three variables involved as x, y, and z. So it clearly does not represent any lines which require only two variables. So option B and C are simply discarded. Now, let's break this equation by taking y as a common factor. Now, we have two parts of this equation where the first part is y equals 0 and the second part is x plus z equals 0. These are the equation of planes, so let's rewrite them into standard equation of plane in the given format as ax plus b y plus cz equals d. For any two planes to be perpendicular, the sum of the product of their corresponding coefficients must be equal to 0. In this case, also the sum of the product of the corresponding coefficients resulted to be equal to 0. Hence, the equation x, y plus yz equals 0 represents a pair of planes perpendicular to each other. Let's check for the options. Option A is the correct option. Moving on to the last question. Question number 25. The projection of the vector 2i cap plus 3j cap minus 6k cap on the line joining the points 3, 4, 2 and 5, 6, 3 is? And the options are 2 by 3, 4 by 3, minus 4 by 3, 5 by 3. The solution is followed as: let u vector equals 2i cap plus 3j cap minus 6k cap. A vector equals 3, 4, 2 and OB vector equals 5, 6, 3. The line vector A be formed by joining OA vector and OB vector is V vector equals AB vector equals OB vector minus OA vector. So V vector equals 2, 2, 1. Now the projection of U vector on V vector is given as U vectored V vector divided by the norm of V vector. On numerator, the dot product is computed by multiplying corresponding elements of the vectors and then summing up, where in the denominator the norm is evaluated as root under the sum square of the elements of vector v. The final output obtained is 4 by 3, which is provided in the option B. Therefore, option B is the correct option. Thank you so much for watching the entire video. Hope you got the required insights needed for the preparation of entrance exam. Do watch our other videos that cover sections like computer science and technology, English, logical reasoning, and statistics. Best wishes for your preparation. We are fully assured that you will crack the examination with good grades. Do forget to like, comment, share, and subscribe to Data Science Nepal.
See you in next video.
Have a good time.